Hi everyone, welcome to part 2 of our 2.3 lesson. Really short, quick video here looking at properties of parallelograms. Let's go ahead and first start talking about what is a parallelogram. A parallelogram is a special type of a quadrilateral, and a quadrilateral is a four-sided object. So this is an object with four sides. That's where the word quad comes from. So four sides. And it's a special type of quadrilateral because the sides that are opposite from each other are parallel and they're equal in length. Okay, so there's a couple of types of objects that will be parallelograms. For example, squares, rectangles, and rhombuses are all parallelograms. We'll look at a couple of these in just a moment. What's true about a parallelogram is that angles that are across from each other, opposite from each other, are equal. So let's go ahead and look at an example here. Let's look at a rhombus. So if I have a rhombus that is a parallelogram, there are two sets of parallel lines here. So this could be, the rhombus will be, let's say, from A to B. Okay, is my first line, and it is parallel to a line below it from D over to C, and these are equal in length. Okay, a rhombus is sort of like a rectangle shifted to the side, and the lines that connect them there, so from A to D, will be parallel to the line from B to C. So not only is it parallel, they're also equal in length. What's true about a rhombus or any parallelogram is that the angles that are across from each other, opposite from each other, are equal. So angle A in this rhombus is equal to angle C. Okay, angle A equals angle C. And it's also true that angle B is going to be equal to angle D. So those are features or characteristics of parallelograms. We could also look at a rectangle or a square. Let's go ahead and draw a rectangle for ourselves. A rectangle is very much like a rhombus, except it's not on its side. A rectangle, the parallel lines meet at a perpendicular 90-degree angle. So, for example, if I have this line E to F, okay, and a line below that's of equal length and is parallel H to G, and I connect E to H, that other line meets at a 90-degree angle. Okay, the horizontal and vertical lines are perpendicular. They're meeting at 90-degree angles. And so all of these angles here at each vertex of my quadrilateral are equal to 90 degrees. And E to H is parallel and equal in length to F to G. Okay, I can see by looking at a rectangle that if each one of those angles is equal to 90 degrees, that means that the total sum of angles, all four angles, have a sum of 360 degrees, because 4 times 90 degrees is 360. That's true for the rhombus as well, and that's true of any of our parallelograms. So all four angles have a sum of 360 degrees. Okay, that must be true. So we can use some of these, again, these relationships to solve a question or prove that a quadrilateral is a parallelogram, just by knowing the relationship between the angles, that those opposite angles must be equal. Let's go ahead and do this last question. It says the quadrilateral MATH, math, is a parallelogram. Okay, so right away, as soon as I know that this is a parallelogram, I can go ahead and say a couple things are true. If this is a parallelogram, then I have two sets of parallel lines. So from M to A, That line right there is parallel to the line below it here from H to T. And I also know that we have another set of parallel lines, so from M to H, okay, that's parallel to the line AT. So we have two sets of parallel lines here. If we were given two angles of this parallelogram or quadrilateral, if I was given angle M and I was told that it was 105 degrees, and I'm also told that this angle MAH is equal to 35 degrees, okay, could we determine the remaining unknown angles? Absolutely we could. Okay, so let's go ahead and do that. So we're given those two angles, and let's find the others. One thing I know is true about a parallelogram is that opposite angles are going to be equal. So I know that angle M of 105 degrees will also be equal to angle T over here. So this will also be 105 degrees. Okay, that's true. Opposite angles are equal. In a parallelogram. All right, great. I could also easily here solve for the angle MHA. So let's come over here and solve for this one. Angle MHA is part of a triangle MHA. So I could determine that that angle there is going to be 180 degrees, subtract 105 degrees, and subtract 35 degrees. Okay, so this is the third angle in a triangle, and therefore it's going to be equal to 180 degrees, subtract those other two angles. So angle MHA is equal to 40 degrees. If I subtract 105, 105 and 35 is 140, 180 subtract 140 is 40 degrees. So there's my 40-degree angle right here. Okay, great. I could also find this angle down below here. So this angle here, this is the angle AHT. And what I recognize about that is that I have two parallel lines. My two green parallel lines are being intersected by the transversal line A to H, which means that this angle of 35 degrees here, this interior angle, will be equal to the opposite or alternate interior angle right here. So I have that Z shape, which tells me that those two angles are going to be equal. Okay, so it's equal to 35 degrees. Why? Because alternate interior angles are equal. And I know that I have two sets of parallel lines there, so those two angles are indeed on the inside of two parallel lines. So this is equal to the angle angle MAH. Okay, was equal to that other 35-degree angle that I was given. I only have one last remaining angle to find here, and it's this angle over here. This is the angle HAT hat. And there's more than one way I could solve for this angle. I could recognize that it's part of the triangle below the triangle HAT, and so I could subtract 35 and 105 from 180 degrees. Or I could just quickly recognize again that it is also an alternate interior angle. Forms a Z shape there, sorry. Okay, because my blue lines are parallel lines as well. Okay, that line from H to A is a transversal line that intersects my two blue parallel lines. So I know that it is going to be equal to 40 degrees. It's going to be equal to the angle MHA, which is 40 degrees. Again, the reason for this is alternate into your angles. And so that tells me that those are equal. I've solved for all my angles inside my quadrilateral, inside my parallelogram. And so we can use all of these different relationships between parallel lines, angle relationships between parallel lines, as well as the relationship between angles in a parallelogram to solve for questions that are similar in nature to this one. I'd like you to try now in your textbook on page 90, questions 3 to 7, 10, 12, and 15. You can check your answers in the back of the textbook. Good luck, and thanks for joining me. Bye for now.